In today's class, we're going to learn how to use Inventor in order to make a part file that looks like this. This is a guide block is what this is, a guide block. We're in Inventor right here. Let me maximize that for a minute. Inventor Professional 2019 is the software we're using. We started the software, and the things that we're looking at are making a new part. We have choices to make a new assembly. We have the choice to make a new drawing. And we have the choice to do a presentation. In our case, we're not going to make a presentation where I can put something in animation mode. I won't do that. We're not going to create a detailed drawing yet. We'll do that later. We're not going to do an assembly yet, but we are going to make a part. And the part we're going to make is this guide block. So when I click on New Part, if I just click on New Part, it'll go through the gymnastics of starting a file. The key to understand is what units of measurement the new file is in. The default setting for Inventor is inches. Just like the default setting for AutoCAD, its sister product, the 2D version, is inches. They both come from a manufacturer called Autodesk. Autodesk is located in the United States, so that's the reason. So if I'm in here and I realize, oh no, my part's really in metric, I'll show you that on a different day. You'd have to change the way you start your file. I'll show you just real quick, just so you know and you have it in the video. When you go to New, instead of picking these icons, you actually pick it from a template. That's how you make sure you can choose what units to build from, okay? So you can automatically, not automatically, but you can intentionally pick metric to make a metric part, okay, versus the standard default inches, okay? That's just a quick show there, just so you know. In our case, this is an inch part, so we're okay. We're just going to let it be. But that's the way to switch out. Now, to the left is our model tree. That's the term they use in industries, model tree. So whenever you hear your boss say, did you look at the model tree? You'll know what they're asking you. They're asking you to look at what's on the left side. Typically, it's there. Okay? Sometimes some people remove it or shorten it up really tight. See that? And you can do that. And we'll talk about what to do with it later. But for tonight's conversation, I just want to get through how to make this part. Okay? So the first thing I always recommend you do is open up your origin so you could see all your planes. You cannot make in any software package, I don't care if it's Inventor, SolidWorks, Solid Edge, Unigraphics, maybe CAD Key, I can't remember. KeyCAD, it's been too long for me for that product. But for the other players, everything is built using sketches. And in order for you to draw a sketch in the third dimension, which is what we live in, 3D modeling, hear that noise? I need a place, a piece of paper to sketch on, okay? Those of you in this room, you see me holding up a piece of paper and a pencil. If you're online, you don't see that, so I'm gonna try to, that's a piece of paper, that's a pencil. So there you go. So you have to turn your planes on, which are actually your base pieces of paper to draw on. So the way to turn them on is you click once on them, right mouse button, and you have the option for visibility. Inventor tends to use words. Other products might use visual icons of some kind. For example, in SolidWorks, they have an eye. They use a visual indicator. In Inventor, they use the word visibility. They just use that word. So you could turn them all on by clicking once on it, right mouse button, and say visible. Click on it, right mouse button, visible. Can you do these all at once? You bet. You can click on the first one, click on, I'm sorry, hold your shift key, click on the last item, right mouse button, and visible. Well, because half were visible, it made them all invisible. So pick the first one, hold your shift key, pick the center point, let go of your shift key, right mouse button, visibility, poof, they're all on. It is good to have your planes on as well as your axes and your center point, okay? That way you'll have everything visible. Inventor tends to use photo-negative colors, which is nice, so they have some good contrast. Other products don't, just so you know, when you're thinking about contrast. Every product you can change the colors on. So if you don't like the color scheme, yes, you can customize it. I'm not going to discuss that tonight. The other thing that I always say is remember to go home. That doesn't mean you pack up right now and leave the room. But I like to tell people, here's home. See that little house? So home is the standard isometric view. And you have the cube right here. That's front, right, and top. So I always like to say respect the cube. You're going to hear me say that. So go home and respect the cube. So you want to know where you are in space. This is what it sees as the front. What's the front? The XY plane. Write that in your notes. The front is the XY plane. Inventor chose not to give the plane the name of front view because defining a name of that nature also defines to us a perspective, correct? So I like to talk to you guys because you sit across from each other, and I do in class a routine that say, where's the front of your table? The front of the table you're at's there. And then your partner across from you, where's the front of the table? By your side. So, but the reality is, it's based on perspective. You two are sitting across from each other. So the front is where you are, not where they are. So that's what I like that Inventor doesn't do. They don't name their planes with the presumption that you know what the front is, because you really don't. They use the more generic geometric terminology of XY plane, but you can put next to it that it perceives the XY plane as the front of the object. Because over here in the icon, in the cube, they use the word front. So if I go home again, and then I click on the right side, it says right, and that's the YZ plane. So write that in your notes, the YZ plane. If you go home again, and you click on the top view, that is also known as the XZ plane. Now for those of you that are machinists, the top plane, as far as you're concerned, is going up in the air where the tool is coming down on a mill, correct? Nope. Right, it's the horizontal plane. The X, which one is XZ or XY? The XY plane for you is what I would call the top plane. Yeah, see the difference? So here, just appreciate what it is. This is called the XZ plane, what you are accustomed to calling the XY plane. And I know that, because as a machinist, that's what we look at, right? And we're going to program the CNC. Hello, what just happened, right? It's okay. The product is able to work with the CNC without a problem, even though it uses this terminology. Don't worry about it, okay? So, but just so you're aware, that's what it's doing. So, top plane is XZ. Front plane is XY. The right plane is YZ. What's really cool, if I didn't like the names of these planes, if I double click on it, I can change you to, let's say, Xena, just for fun. I can change this to Henry, see that? So all of a sudden I've renamed my planes. How about that? So when you're at a company, you might find that they've renamed their planes. So they might not even use the plane names that you're accustomed to seeing. Got it? I did that intentionally just so you're aware. So what is this one supposed to be? What's the right side supposed to be called? Just so I don't mess all of you up. Is that one X? No, the right is X. YZ? I don't know. YZ. I don't know. You're telling me YZ. I know, it's terrible. Yes, yes, yes. And Henry really should be called X. X what? XZ. XZ plane. Whoops, how about I learn how to spell? There we go. Got it, guys? Alright. So, just so you know, you can rename them, so anticipate at a company that if they might be renamed. These axes are very powerful tools, and you're going to learn how to utilize them in the future to make things on different planes. Your center point is also a very, very useful tool. Okay? So to make this part, the first thing we have to think about is how we're going to make it. So the first step is sketching out what you think it's going to look like. I can't really sketch in this mode that I'm in, so I'm just going to have to walk you through it. Because of the orientation of the object, so I'm going to use my hand here. This is when I wish I used my tablet instead of the computer here, because I can't really mark on this paper. I don't think I can. Let me find out. No, I can't, because this doesn't have Adobe Writer. It's only Reader. Okay, this thing right here, where my hand is right now and just turned into crosshairs, you see that? That is what we will call the front view. The only reason we're going to say that's the front view is because its orientation matches this one, the cube. So we're going to respect the cube. And that's the front plane. Got it, guys? That's the only reason. So, and then the right side is this side that I'm moving my hand on. And the top is up here. Okay? Now the bigger question is, do we start with the front? Or should we start somewhere else? The answer, the short answer, is you start in the plane that has the most geometry in it. Meaning the most unique silhouette. Did you hear that? So the footprint, whatever plane has the most geometry that you can pick off at the same time, that becomes your front plane. And generally speaking, in an engineering graphics class, your front view is the view that has the most details in it. Got it? Anyways, so they do tend to match each other. So it happens to be that the front of the object would be a plane that I want to start on anyways. Got it? Now, you cannot put your mouse inside the yellowish area in order to pick a plane. You can do that in other software packages, but not this one. All right? In order to activate your plane, which is your sheet of paper to draw your sketch on, you actually have to touch the edge of it, the very yellow piece of it, or pull it off of here, off your model tree. I don't care which way you do it, it doesn't matter. If you go off of your model tree, just right mouse button and pick New Sketch. If you're out here, you get the option New Sketch. Now inside Inventor, creating a sketch looks like a bunch of little lines and a pencil attached to it. All right, guys? That's just their idea of an icon to indicate sketching. All right? When you click on that icon, it actually rotates the view to where you are. Okay? That sound effects, sorry guys, you'll have to hear it on the recording as well. Now, up here, it automatically brought me to my sketch tab. Now I had to minimize everything so you could see everything. If I try to scooch everything over a little bit, it's not going to do much for me. To try to show me more of the toolbar. There it goes. You see that? As I increase the size of this window, boop, 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 these pop up a little better. So I'm going to try to do that for you, but everything else gets smaller. Just be aware of that. Okay? So we haven't talked about any commands yet, but you are in sketch mode. Visually, how do you know you're in sketch mode? Number one, you're in the sketch tab. It's bright green, whereas everything else is not. Number two, in the upper right corner, you see Finish Sketch, which means you're in a sketch. Number three, in your model tree, everything is gray except the sketch that you're in. It's bright. It's got a white background. Those are your visual cues. In the previous release of the software, the other cue was that a grid would appear. I guess enough people didn't like the grid that now the default is no grid. But you could turn the grid on. It would be very similar to what you would see in AutoCAD. Not as dark. It's like a grayish looking grid. That's up to you. You can activate it. On these computers in the lab, no go. Can't do that. Because our computers, when you shut them down, remember they have a lobotomy. They forget everything. When you turn them back on, whatever changes you made are gone. Which also reminds me, do not save on these computers. If you save on these computers, you lose your work. Early on in your education, that's okay, because that just means that you get to practice to redo your work. So that's the plus side. The negative side is you have other work to get done, you're going to run out of time. So save on a flash drive, email to yourself, whatever, but don't save to these computers. Next. All right, this shape, when I look at the front of this, it looks like it's got a wedge in the front. It's got another wedge up here. It's got a flat top. It's got a little step in the back. See that? It's got a hole smack in the middle of it. Some, maybe not in the middle of it, but it's got a hole in it. All right? So, I wonder, how far should we go? In AutoCAD, we'd go all the way, including putting that hole in, right? If we were in AutoCAD. But in Inventor and any 3D parametric CAD package, I always recommend that you make a basic shape and then you whittle away at it a whittle at a time. That's the way I like to phrase it. All of your extrusions, all of your additional features, everything you add to the part needs to be done first. And then I recommend you start cutting away at it. Okay? That's the way I would do it. So let's build a basic shape. So how do we do that? We have the line command. And we click on our down arrow. The line command also includes splines, different types of splines. Equation curves. We're not going to use these today, but we are going to use the line. There's also a circle. We have the circle command. You have center point, tangent, and ellipse. I know an ellipse isn't technically a circle. It's made up of a bunch of circles and arcs, but they put it under the circle command. All right, so make a note of that. The arc commands, there's 3 choices, and you're going to find even when you get in there, you're going to have more choices in each one of these. Rectangle. Rectangle has a lot of choices. Within the same family, you have the slots. Not just straight slots, but curved slots. And polygon. Okay? They're all in here. A little to the right of that is the fillet and the chamfer tools. They always seem to go hand in hand, fillet and chamfer. In most products, they're usually within the same tool group. Then you have text. This isn't merely putting text on the drawing. You can actually utilize this text to cut the letters out of the part. So it's kind of a neat feature. And then there's geometry text that goes on a curve. So if you were going to make a beautiful plate and you wanted to etch some words on it on a radius, this would be the tool to use. Okay, and these are all in the part called Create. Okay, and all of it belongs to the tab called Sketch. So this section called Create, we call it a toolbox. That's the term that they use. The section right next to it is called Modify. That's another toolbox. Okay. and then there's pattern, and then there's something called constraints. Okay? Constraints is where we define the geometry in two ways. One, physical, like geometric constraints, perpendicular, parallel, tangent points, things of that nature, vertical, horizontal, concentric. And there's the other kind of constraint, which is a constraint of numeric value, a dimensional constraint. Okay? So there's two types of constraints, a constraint of geometry and a constraint of dimension. Got it? So put that in your notes. And this comment that I just made about the two types of constraints is universal. I don't care what software package you're using. It could be SolidWorks, Inventor, Pro-E, Solid Edge. I don't care, Edge. I don't care a 3D CAD package. They all operate with those same two premises. All right? Not necessarily executed the same way. Just like a car, all these different types of cars get us from point A to B, but we have all different types of cars, right? Some actually have a key start. Some actually have a push button start, right? Cool. So, but they're all cars. And that's what it is with CAD packages. They're all the same, but different. So, how should I start? Should I start with a line or maybe a rectangle? Any thoughts? Any preferences? Let's start with a line. Why not? Okay. When you look at your mouse, there's a little yellow dot that follows your crosshairs. Here's my personal advice. I like to be grounded in the beginning of my model making, which means I really want my part to start at a known location. So I always want my initial sketch, my very first sketch, to be somehow related to my 0, 0 position, my XY 0, 0 position, especially if I'm a machinist. Then it's even more important because I'm a lazy programmer. Okay, if I build this correctly, my machining job will be a lot easier. If I build my part off in La La Land, my machine's going to see it off in La La Land. I got to drag it to the 0, 0 of the machine. It's an extra step, and some people say, who cares? But I am that lazy, so I care. So to do that, by the way, lazy means efficient. Just translate it to the word efficient. When you hear me say lazy, just so you know. So when you move your mouse to the intersection, remember we turned everything on, correct? Because we turned everything on, we have access to everything. Isn't that beautiful? Okay? So I'm going to move my mouse, and you see how it turned. Here's my yellow dot, following my crosshairs. And poof, see that? It is going to lock down. See how it turned into a green dot? It is going to lock down at that intersection. Do you see that little arrow with the little red dot? That's telling me that's where it's going, which is going to lock down geometric constraint. That's a constraint of geometry that you see, that little icon with a little arrow pointing to the red dot. That it's going to lock itself down to that point. Did you hear that? Okay. When I click there, then I can actually just take my mouse and move it to the side horizontally. You want it horizontal or vertical? How do you want me to start? Horizontal line or vertical line? Horizontal. Okay. I let go of my mouse, and you're going to hear me say that in class during lab time all the time. Get your hand off the mouse. So you mouse dependent people, stop it. You'll notice when you move it over, you see that box that has that number in it? 0.625. It even tells you the units, IN, for inches. Well, what's the length of this thing? 3.75 based on the drawing, correct? So we're going to type that in, 3.75, and we're going to hit enter. And poof, not only did it drop in the physical line, guess what it also dropped in? My dimension. So talk about lazy. Get it? Now watch this. I'm going to go at an angle. Guess what I can manipulate? Both. the degrees and the length of the line. Annoyingly, do I really know the length of this line? The hypotenuse length, to be specific? I know that 60 degrees, but I don't know the length of this hypotenuse, do I? So I really can't utilize this tool with high efficiency, can I? Not yet. Okay? Yes? Let me finish this and I'll tell you. That's the sad part. You want to go back. You want to start a new line? Is that what you're thinking? You want to undo? Okay, to undo, let me try it. No, that doesn't work. Right mouse. Ooh, look at that. Look at the right mouse button, guys. I get a bunch of choices. Undo is not, sorry, undo is not one of them. So, say again? Control Z. Let's try it. Control Z. Nah, Control Z does nothing. I'm hitting it. Good idea. So my 10 cents is it's okay. Just leave the line there. But you can end this line right now by just hitting, oh, not that key, not that key, that key. Now that key, I intentionally hit 3 keys. Sorry, you can't see it on the video. The third key I hit is my favorite key on the keyboard, Escape. Got it? So when you're done drawing the line, hit the Escape key. Okay? Earlier today I was doing AutoCAD, so of course the first thing I hit was a space bar, because we all do, don't we? Even though it's an Autodesk product, the same maker as AutoCAD, it still has its own little idiosyncrasies. I could jump back in the line command, hit a line command. Now, if I write my notes, we're doing the line command, and that's found where? In the Create toolbox, right? Okay, the Create toolbox under the Sketch tab, right? Okay, just so you know where that is. Okay? Next, we're going to drop another line. I'll start at that intersection and go straight up. What's that height? I can stop at the 1.25 if I see that. See that? So the 1.25, whoa, what's wrong? Before I hit enter, it's not vertical, right? It's like at 92 degrees. So I hit escape. I told you my favorite button on the keyboard. Did you notice that? I can stop myself. I can fix it too. Now when I put my line vertical, I get another little picture. That little picture means vertical. It shows a line with a little red hatch next to it. You see that? That's vertical. That's the visual constraint that tells me that's going 90 degrees. The other one, of course, is the fact that it says 90 degrees. Okay? So I want it to go straight up 1.25. I hit enter. Then I go across. I go across. Now what do you see? Ooh, we see more things. Look at that. You see two different constraints and a third one on top of it. On the left side near the 1 point, I can't move my mouse, sorry guys, so I have to verbally describe this. The height of 1.25, you see, looks like an upside down T. Do you see that one? That upside down T means perpendicular. It's exactly the same one you'd see in math class, in geometry class, in metrology, GD&T symbols. Got it? So it's perpendicular. The other one is the vertical reference, and then what you're seeing is that other line is just saying, hey, I'm going somewhere. Don't know where, but I'm going out there. The red line. What's that length, guys? 0.75? And now it's going to go up. It's going up. Oh, I don't know what it's going up. See, I don't have that information. It doesn't tell me the height here. I know this. I know this depth is 1.25 up. And I know this final dimension is 1.75. So do I need to pull out my calculator and start figuring out the math? Or if I'm really good at math, I can figure it out in my head. But I try not to do anything in my head because things get jumbled in there too many times. So let me try what I think is the solution. 1.75, which is the final height, minus the known height of 1.25. Whoops, if I can learn how to type. 1.75 minus 1.25. And I hit enter. And that's what it did, the difference. See that? It even threw the dimension in for me. Now I have to go across and I have the same problem. What problem is that? It's another math problem. It's 1.5 minus 0.75. Get it? I can type in the equations. Unlike AutoCAD where I'm limited in how many places I can do that, like you can use it in the offset command, in here I do it for everything. And not only can I just type this equation in, I can actually start putting in some real relationships and actually incorporate function of x formulas in this thing. Another day. Don't worry. Not today. There we go. Now watch. I want to go at an angle, but I'm back to that problem. I really don't know the length of this hypotenuse either. Hippopotamus, whatever we want to call it, right? But what do we know? We know that its angle is 25, correct? And we know that this angle is 60. So basically what we're saying is wherever the two intersect, that's where you stop. Oh, do we know where the two intersect? No. Honestly, do we care? They don't care. The customer doesn't care. The customer cares that the angles are maintained. Yeah, there is a true length to this, and there is a true length to this angle as well. My machinist cares. He's laughing at me over there in the corner. He's like, I care because I need to know how far to travel my tool, right? Yeah, that would be helpful, yes? So you care, but the rest of us don't care. So for you, we'll make the print correctly. For the rest of us, we don't know the length of the hypotenuse, but we certainly know the angle. But here's a small problem. Is this giving us the angle the way we know it? Or what is it giving us? The complementary, right? Is that the term in math? You've got the two complementary angles that equal 180, correct? So basically what we're saying is we want it to be 25 degrees from 0 position, and it's giving us the 141.5 degrees. So I'm going to say that I need to do what? Right mouse button and do what? I really want to do what? I'm too lazy for this, but I'm going to show you. I want to do what? I want to change this, right? I don't want to change this. I want to change this. Got it? So if I click on here, what am I going to do? 180 minus 25, right? Because that's what that's going to give me, 25 degrees. Now what else did it do to me though? It made this line static in length. You notice that? If I don't like the dimension because I don't know the length of that hypotenuse, I can always pick it and delete it. And there's your 155 degrees. Okay? And I can actually delete a lot of these dimensions. For now, I'll leave them in there because we'll go ahead and clean it up after we're done putting the shape together. So now I'm going to go back to my endpoint here. Now, what was the length on this one? We don't know. But what do we know? I want to change its degrees. So I have to do right mouse button and click the degrees. It's 60, but look how it's giving me the information. So what is it? 180 minus 60, correct? 180 minus 60. Are the two touching? Nope, so I messed up. Maybe. But I didn't know how long this was anyways, correct? So it doesn't matter. So how can I fix it? Well, let's talk about that. In AutoCAD, we use like trim or something, or extend, correct? And also we would utilize something like grips. Inventor also has grips. When I click on an object, I don't see the grips like I would in AutoCAD. But if I drag the endpoint out, I can connect it to another object. So if I drag an endpoint back, I can connect it to another object. Here you're going to see that it's connecting to intersection. See how it's got a little X with a little arrow to the other X? That's what that means. So did I connect them? Yep, they're connected. What color is the object? Blue, a very dark blue. On the bottom, near the bottom right, it says fully constrained. If you see that, that means your object is fully defined by the terms of the software. If I start deleting dimensions, let me just do that, objects are going to start changing color. And the color they change to is green. Green means that I need to apply a dimension. It's not fully constrained. And now all of a sudden it says 2 dimensions needed. Okay? Now I'm going to be a little annoying and I'm going to start deleting some other dimensions too. And you're going to be like, wait, you're taking too many away. That's okay. There's a reason. Whenever you show dimensions like this, any dimensions that appear on your sketch, in your model, directly translate to your detailed drawing later on. Did you hear the way I said that? So whatever dimensions you put in your model, they directly, automatically will appear in your detailed drawing. So if you would like to be as lazy as me, you will try to only put the dimensions in your model that you would like to appear in your detailed drawing so you have less cleanup later on. Does that make sense? Because the name of the game is efficiency. I don't want to have to delete the 155-degree angle in my detailed drawing and put in the 25-degree angle that the customer really wants to see. Got it? The customer didn't tell me this is 155 degrees. They said it's 25. Their tolerance is attached to the dimension that they care about, not the dimension that Inventor dropped on your model. Do you hear the way I said that? Software doesn't know anything. Software is ignorant of the customer's specifications. You have to control the software. The software, in order for me to build this, dropped 155. I get rid of that and I drop in an actual true dimension, picking this line, and I drop in the real dimension, the one the customer is expecting to see, 25 degrees. Yes, the answer is the same. Whether I put in 25 degrees or 155, the mathematician's going to say, who cares? The answer is the same. I'm like, the tolerance is not the same. To the customer, they want to see the tolerance assigned to the 25 degrees, not to the 155 degrees. And you have to do the drawing that they have to sign off on. Does that make sense? If I drag this guy, whoops, let me hit escape real quick. Drag this guy over, it doesn't flip to inclusive angle versus exclusive angle. Got it? So I have to delete that dimension and drop in the correct dimension that the customer is expecting. It would help if I picked dimension. Sorry, guys. See that? That's the dimension the customer wants to see. So when you look at the toolbar we're in, this tab is called Constraintd. So you have dimensions that are in the Constraintd. If I could learn how to type, Constraintd tab. Got it? You're with me? Got it? Cool. 60 degrees. Done. Now, again, this one's very important. You see that 3/4 of an inch there, the 0.75, and you see the 1.5? Okay? A tolerance to 0.75 could be plus or minus, hypothetically speaking, 1/8 of an inch, which is an absolutely horrible tolerance. We know that. So the machinists in the room, don't get mad at me, because I know you wouldn't operate to an 1/8 inch tolerance. But an 1/8 inch tolerance is 1/8 of an inch, right? 0.125 inches, correct? And the 1.5, let's say it has the same tolerance, which is 1/8 of an inch. So hypothetically speaking, what's the maximum variance you can have on the 1.5 dimension? If it had a plus or minus tolerance of 1/8 of an inch. It could be as small as 1.375? No, is it? What's 1.5 minus 1/8? I don't have a calculator. Sorry. I shouldn't do this. I know that. I'm so guilty of doing this. Talking and recording at the same time. 1.5 minus 0.125. I was right. 1.375. Or it could be the other way. 1.58. I'm sorry. 1 5/8 would be the other direction. Got it? 1.625. Correct? If I assigned an 1/8 inch tolerance to these two, these are stacked dimensions, they're right next to each other. 0.75 with 1/8 of an inch is 0.875. 0.875 plus 0.875 equals what? It is 8 plus 8 is 16. 1.75. Is 1.75 tolerance acceptable if the customer really gave me a 1.5 inch dimension with a 1/8 tolerance? That means the max is 1 5/8. You cannot leave these dimensions on this drawing the way they are. And you can never give them to production because they will make it wrong. The tolerance is too great. Because stacked tolerances are dangerous. You actually have to delete this one and put in the correct dimension, which is from side wall to end point 1.5. Because now the tolerance isn't compounded. Because when you have two dimensions butt up next to each other, that means you're compounding your tolerance across all those objects. You can't do that. Now the SolidWorks or Inventor, in this case Inventor, warn you when it drops dimensions that it actually can impact your tolerances? No! You need to know that. That's why I'm making it a conversation piece right now. When we made this object, just like this one, we made it expediently, but not correctly. It's expedient, but now we have to go back and correct the dimensions to be exactly the way the customer showed it on their drawing. This is their drawing. Got it? Are you with me on that? So you fix all those dimensions to reflect what the customer drew. Because are you going to remember that when you do the detail drawing for this part? No, you're not. I guarantee you. Remember, whatever dimensions you put in this model, they will directly translate to your detail drawing. And that is the number one complaint companies have. The detail drawings just don't look right. Why? They're putting in dimensions that don't even belong there. This is literally their complaint. Why? Because I'm not teaching you properly. I'm supposed to tell you that dimensions have meaning. And when you put in dimensions that don't have meaning, they mess up the drawing. They mess up production. So you always make sure you fix these dimensions before you are done with your sketch. And make sure they reflect what they really need to be. All right? I don't want you to draw in a haphazard manner, because then you'll do that at a company, and I don't want you to do that. So there you go. When we're done creating a sketch, and we're done putting the dimensions in, should we put the hole in, guys? Or should I wait? Wait. Remember what I said? Let's build a basic shape, extrude everything, or revolve everything, and then turn around and whittle away at it a little bit. So that's what we're going to do instead. So there's my object. In order to extrude, here's the cool part. I can do a right mouse button and finish my sketch. Okay? Or I can go ahead and jump straight to 3D Model tab, straight to 3D Model tab, straight to the 3D Model tab. I'm in Sketch, which is nice, bright, and green. I can switch straight to the 3D Model tab, which is a tab to the left of it, and pick Extrude. Whoops, I mean that. See that? Cool? I don't have to do extra little steps. Got it, guys? So Extrude is right here. It's under the Create toolbox of 3D modeling. So I'm going to type that in. Extrude, which is under what? I forgot. 3D, what's it called? Actually, that's the tab. But what's the toolbar? What's the toolbox called? Create. Create toolbox. Under the I forgot which tab it is, guys. I don't know. 3D tab. 3D tab. Got it? 3D tab. Extrude. Look what it did. It zoomed in and jumped into extrude mode. Now, you notice how I rolled it back and rolled it forward? Okay, you can do that. The way to do that, if I roll the wheel toward me, it zooms in. If I roll the wheel, the middle wheel of my mouse away from me, it zooms out. Got it? Put that in your notes. To zoom in and out on the fly, you roll your wheel. Roll your wheel towards you to zoom in. Roll your wheel away from you to zoom out. If I want to pan, hold the middle wheel down. Can you reverse it? Sure. For those of you that want to, I don't care. That's up to you. You can customize anything. Next. Oh, wow. What did the customer forget to tell us? The front to back dimension of this object. But we called him. We knew this. Mr. Jahai called him, right? We found the answer. What's the answer? He doesn't want to say it out loud because it's recorded. The answer is 1.5, if I remember correctly. 1.5. So we're going to extrude this whoops, I guess I should be in here. Sorry, make sure you're inside the dialog box, right here. 1.5, you type that in. Now notice it wants to extrude forward. Notice that the part is relatively symmetrical. I could extrude forward if I want to, which is distance. I can extrude to. I can just extrude between. See that? I'm going to pick distance. Within distance, I can extrude in one direction. I can extrude in the other direction. I can extrude midplane. I'm going to pick midplane just for fun. Okay? Because it splits the part in half. And on top of it, I can extrude asymmetrical, which means I can have a different distance extruding forward than backward. Why? I can't answer that question, but if it ever comes up at work, you can do it. Okay, so I just picked midplane. It splits the 1.5 in half, and it does the extrusion in that manner. It picked the profile automatically, and we just hit OK. And that's it. That's your basic shape. Now, when we look at the next step, one of the things we realize is that the walls of this object, the exterior walls, are common all around. They're 1/4 inch. So now I'm going to teach you a new command called shell. Not the gas company. It's a command called shell. Now think of what shell is, like an egg shell. What do we know about eggs? They're hollow on the inside. They got stuff on the inside. So they have a thin wall to them, right? So the shell command is about making something with thin walls. Or it doesn't have to be under a particular thickness. It's just that's the word, the analogy. Where did it come from? That is under the toolbar called Modify, which is also in 3D Model. Okay? Modify, as I've always argued in every single software package, is where the power of the product exists. You can take the effort of creating a shape and cutting this out and really going through a lot of labor. But that's really not where the power of this product is, of any product. You'll always want to snoop around in the Modify toolbar of any software package you ever get your hands on and see what can I do. Got it? because that's really where the power of the software package is. For example, when I was doing AutoCAD earlier today, it was what? Three commands inside draw, and the rest were all modify commands. Because that's really where the control is. It's all in modify. So we're going to pick the shell command. And the shell command is where? Modify toolbox. I can't spell again. Modify toolbox under the 3D tab. Okay? That's where it's located. Under modify, and it's shell. It looks like a box inside of a box. And if you leave your mouse long enough, one thing I absolutely love with Inventor, and then it shows you a picture. And if you want to know more, just hit F1, and it goes into a whole explanation. Poof! Of explaining how that works. See that? That's what Inventor does for you. So you can start playing with the product, whatever thing you want to make, and see what you can do on your own without somebody there walking you through it. Because the last time I checked, you don't want a person at your elbow at the interview. And besides, I don't think they like it when you bring somebody along with you to the interview. So, but they're going to do all my work for me. What? We're going to hire you, not them. Got it? So you may as well start playing with the product. Shell. Now here's how shell works. If you do nothing, and let's say the only thing you pick is the thickness, I type in 0.25. If you look at the actual model, you see how it looks like it's got a little red box inside of the big box? Basically, you're making the equivalent of a chocolate rabbit. You know, in the holidays, or it doesn't matter whether you like whatever holiday it's for, who cares? But we like chocolate, right? We all like chocolate, but can't resist chocolate. Anyways, they're hollow, the hollow bunnies, that's it. That's if you do nothing and all you say is, I'm good, and you hit OK. You're going to have a hollow interior, which maybe that's what you want, but more often than not, that's not what you want. In this case, that's not what I want. I want to basically remove the top, remove the front, remove the, well, this is like angled front. This is the front. I'm going to click on this and orbit to the back side. I'm going to remove this wall and remove this top wall. See that? Whatever faces you select, it'll just skin those off. That is the true power of this product. And it doesn't matter that it's a quarter thick or half an inch thick. Get it? There will be a point that it will fail. So let me see if I can break it. It should break. I made it 0.75. Let's see if I hit OK. Ooh, goody, it broke. Yay. Whenever you get an error message that says could not create a new shell, that means something is not going to work mathematically. Now what's 0.75? 0.75 times 2 is 1.5. So what is the width of this part? Because we call the client. We know what it is. It's 1.5. So obviously it cannot work. So it's smart enough to know when it can't do it. Now if I pick 0.375 or 675, sorry, it's close, but will it do it? Yep, it will. Got it? But it's really none of those. It's 0.25. Cool? When you hit OK. Now here's something else I want you to see. The default setting is to shell inward. Shell inward. We built this part with the exterior dimensions in mind, correct? We did the outside dimension of 3.75 with the outside dimension that the customer gave us of 1.5. Hypothetically speaking, let's say you were designing an object that fit. You're making the object that this thing has to fit inside of. Then you want to actually shell outside, so your object can slip into it. Got it? That's a very, very useful tool. The two most common shells would be inside shell and outside shell. I'm making a hat or I'm making the head. I don't know how you want to think of it, but I just threw that out as a way to think of it. The third one is not as common, which basically splits it in between. That one's not as commonly used. But the first two are very commonly used. And you see the distinct difference between them. This is shelling inward, this is shelling outward. And depending on the purpose of this item, one is better than the other. In our case, we built our part with the overall dimensions in mind, not the interior dimensions. Make sense? So that's why we're shelling inward. We hit OK, and we're done? No? You guys are looking at me funny. What did I forget? The hole-in-one. I missed the whole point. No, not the whole point. I just missed the hole. So now I got to put that in. That's right here. So the best way to use the hole is under Modify, and it's called Hole. So that's the next command, Hole. It's under the Modify toolbar. I guess I need to change that pound to a 3. Hang tight. Voila. There we go. The whole command is under the Modify. Remember, the power of software packages is in Modify, not in drawing, not in creating. It's actually all in subtracting. So what we did was we built our base model. The method to the madness that I would like you to take, no matter what software package you ever use, is the method of madness to start with the basic model and then whittle away at it a whittle at a time. Got it? And that's what we're doing. I shelled it. Now I'm going to drill a hole through the whole thing. I pick the whole command, and I get a bunch of choices. A whole lot of choices. I know. I'll stop. Okay, if I open this up a little bit, drag this over so I can look at this. The size, placement, let's look down the line. Placement, where am I putting this thing? Okay, it's asking me, where do you want me? I'm going to drop you right there. Oh, sorry. Let me pull that out. Let's see, okay. I dropped it, but what's the problem? Is it in a good spot? We don't know where it went, do we? We do not have the dimensions. So notice what you do. If you take your mouse and drag it to the side, you're going to see a little icon up here of a line with a little dimension arrow above it. When you click on this, it wants to drop the dimension. So I drag this right over my part. Where is that? That's 1.5, yes? So it's 1.5. I was close, but no cigar, eh? Now the bottom dimension is 0.75. See that? That's how this works. So now we've identified the location. Location, location, location. It's always about location. Next. Let me drag this out again. Oh. It locked itself in on the side. Sorry, guys. Let me try to pull this out. There we go. Okay, next. The diameter, this guy. It's not 0.25, it's 3/4, so we have to type in 0.75. Okay? The type of hole. This is actually very important. It's either a simple hole, which is literally just a hole as if I went and took a drill and I took a 1/4 or 3/4 inch drill bit and drilled a hole. The one after it, this is a clearance hole. This is the kind of hole you make a little bigger so that you can put a fastener through. Okay? So you want a clearance hole for a bolt, for example. Let's say you're taking two pieces and putting them together. You don't want to force fit the fastener, so you make the hole a little larger. The next one is a tapped hole, which is literally an internal thread, which we call a female thread, or a B thread, an inside thread. And that you want if you want it to actually hold the nut. I'm sorry, not the nut. Hold the fastener instead of getting a nut. And the last one is actually a tapered thread, which we use in the plumbing industry when you're trying to create a tight seal, a seal type thread. So anything that's plumbing, gas, those types of whatever industry related to gas and plumbing will use that type of thread type. Next, how is it going to seat? Well, that means, am I going to use a counter bore? A counter bore is a blind hole with another hole through it, so you can put a bolt inside of it and make it flush to the surface. Or am I going to, I don't ever know why they do this, but spot face. A spot face is a shallow counter bore. I don't know why they made a point of making it a separate icon. I can't answer that question. And the last one is for woodworking people, which is a countersink, which is a fluted type hole, so that if you have a wood screw, which has that fluted tapered side walls to it, it can be flush to the surface as well. They do it in machining, but not as often. So in our case, it's just a hole. Next, termination, meaning where is it going to end, not is it going to get fired. So right now we've got a specific distance through all, which is just fine with us because you can see that it basically runs through the whole object, which is what we want. Up to a plane, up to a particular surface, so we can actually use a plane to stop it somewhere. And then the direction. Default, it's just going through, people. We don't care. Okay? There are times, let's say the customer, which they did not at this time, they had one diameter hole here, but only on this side, because this was going to maybe just stop a rod. The rod doesn't go all the way through. We've seen those types of holders. Okay? Then you don't want this to go through, so you want it to stop at the back wall of that front piece, right? So that's when you would pick up to, and you'd pick that back wall, so it only drills that front hole instead of through all the way through. Cool? And that's it. You got the 3/4. You can identify that, which you did right here. You can change it again if you want to. That's also in there. When you hit OK, done. That's it. That is your part. So this is your first part that you're building in Inventor tonight. This will be the end of this lecture. Now it's your turn.